Hello and welcome. My name is Rene Neumann and I'm working for ZP Systems. Over the next couple of minutes, I want to show you a blueprint how you can deploy, destroy and change your environments in your edge locations in an automated fashion. But first, let me introduce you briefly to who ZP Systems is. The company was founded 2013 in Fremont in California. The goal of ZP Systems as a company is to resolve the networking challenges large enterprises and hyperscale companies have, specifically around increasing demands of availability, security, and scalability. Specifically, do we offer functionality and solutions for a data center and campus management. The whole solution is built primarily around our third generation out-of-band solution, which is put on top of a zero-trust security platform. The whole solution is designed to provide scalable management access to all of your infrastructure devices, including CEO consoles, IPMI, and many more, and automatically enable you to hyperscale automation. In your branch and edge locations, we offer the same third generation out-of-band functionality, but combine it with connectivity like 5G, LTE, and many others, cloud and SaaS management offering, as well as a variety of different form factors to address the different needs of your edge locations. If you need a cybersecurity platform specifically at your edge location to run, for example, next generation firewall, additional security functionalities like an automated penetration test or vulnerability test, then our cybersecurity platform is the ideal choice for you. We combine the whole solution with an open partner ecosystem and marketplace. Our solution is trusted by many different customers, starting from the hyperscalers over the financial sectors, all the way down to technology and industrial applications. We are deployed globally in many different locations and many different companies. Now, let's take a look at how you can actually implement an automation solution which is based around the maturity level provided by our ONUG working group. If you look at the maturity level, there are many different ways of how you can achieve automation, starting with a very basic level 1, which is task-based automation, all the way up at some point to AOps automation. The ONA layer, though, is dependent on the network management layer to provide it with insight into what is currently happening in your environment, in your infrastructure. So without the data, events, and analytics, which the network management layer can provide to the automation layer will never be able to perform any actions. On the other side, without the infrastructure layer, the automation layer, the ONA layer, has nothing it can react upon. Essentially, the infrastructure layer provides you with your targets for your automation. That can be a physical infrastructure, virtual infrastructure, can be on-prem, or can be in your cloud, or can be somewhere in between. So as you can see, all three layers, the network management layer, the ONA layer, and the infrastructure layer, cannot exist on their own if you want to have a complete automation solution available to you. They all three need to work together to achieve your desired outcome. But now let us take a look at a couple of use cases and examples which you might find interesting in your daily operations. The first use case, which we're going to look in a little bit more detail, is around a security response, like a DDoS attack or botnet, which might have infiltrated some of your devices. The second use case is in real edge zero trust deployment, which is based on the fact that you need a secure platform which you can trust in the edge to bring up an entire edge location or environment and to manage it. Really what you want to achieve is you want to use the same immutable principles which you already have very likely in your cloud and bring them to the hardware layer in your edge locations. Another good example is around disaster response. This can be natural disasters as well as man-made disasters, as we can currently see in the situation in Eastern Europe. The goal here would be to protect your own infrastructure as well as your intellectual property and to limit the business impact and risk. So the real question which you have then in those kinds of situations is, how do you scale that out to all of your different edge locations, make sure that they're shut down, potentially erased, or brought back up after the disaster is over and you want to bring those sites back up. Now let us take a look at the use case around an automated response to a security threat which might have happened in your own environment. Good examples can be DDoS attacks, botnets which might have infiltrated some of your devices, as well as many other different scenarios. What you see here is a process flow which you're going to see in a minute during our demo. We have used specifically the use case of a botnet where a potential botnet client might be already installed on a device, and the botnet tries to actively reach out to its command and control center. In most cases, one of the very first steps what they do is they're trying to reach their own DNS servers. We are going to use that as a trigger to start an automated workflow response. To identify if the client is trying to reach its a dedicated DNS server, we use Kentik's observability solution. Kentik will monitor the data stream using NetFlow, analyze the data, and if certain events are happening, we'll use that as a trigger to send the event alert via webhook to StackStorm. StackStorm is an event-driven automation solution which is open source. Everybody can use it. There's a commercial solution available for StackStorm as well for anybody who would rather like to get support and some more advanced functionality. In StackStorm, we're going to start the automation process. Essentially, what the automation process will do, it will use a REST API call to talk to our ZP System Cloud instance, which is then in turn triggering the automation response against all of the sites which are affected by the security concern. What is happening on the end device in the edge essentially is that you have a physical appliance from ourselves which has a console connection to your firewall, and on that device we will then run the local automation. As a very first step is we are going to create a backup of the existing configuration on the end device. Then we will push the required security change via CLI, and after that change was done, we can then perform some additional tests to ensure that the change didn't break anything else apart from the expected functionality. This can be done through a user experience agent or through some basic scripts or some other functionality. The key here is if that user experience agent then detects that some other functionality might be affected, it can then automatically trigger a revert of the previous configuration. The important thing is here that the revert can happen using the normal console connection. So the previous configuration which we used as a backup can be directly restored, not reliant on any management interface to be available to the out-of-band solution. Now, let me actually show you how the whole solution works together. What you see right now is our ZPE Cloud instance, which is a SaaS-based offering which provides you with our Generation 3 out-of-band capabilities as a managed service. Primarily, you can access your end devices directly from here, and specifically for our demo, we are going to use a FortiGate firewall, which we access through our cloud service. You just saw a second ago a couple of policies are already existing on the device, and I'm just showing you now the network interfaces. Port 1 provides connectivity to the WAN interface, and port 5 provides connectivity to our clients. So the goal is that we can detect, using NetFlow, traffic originating by our Windows client, going out the WAN interface to a specific DNS server, and then we are going to push a policy onto that firewall to prevent that traffic. The NetFlow will roll into the Kentik analytics software. You can see here already some previous events, and Kentik will then raise the event with our StackStorm instance, which will then run the actual automation. In StackStorm, I created our ONUG example. You can see it's a standard webhook which I'm using, and underneath it I'm running a simple Python script which orchestrates the automation in itself. Lastly, you can see our GitHub instance, which we're going to use to store the backups of the end devices. I've created a small integration with Slack just to provide us with a better visibility of when certain actions are actually happening. As you can see right now, the Kentik raised the event in our automation platform in stack storm, clearly telling us which IP addresses are affected and telling us the individual items of the different platforms. So specifically here in Kentik, you can actually see directly in the overview which event happened to which target devices, and you can see as well in our ZP Cloud instance that the current automation process was pushed and it's currently started. The whole process is going to take a little bit. Just to show you as well. So in our stack storm, you can see that the current process is running here as well. And that Kentik provided us with a large amount of different informations, which we can use for our automation purposes. If we go back to Slack, we can then actually see as soon as the process is done. So you can see here the event was cleared in Kentik, as well as that the overall process was finished. If you look at the process in our ZP Cloud, you can now clearly see the different automation steps and the results of those steps. In our case, this was successful. We can verify that by going to the FortiGate and just look at the different policies. Let me log back in. And if we go to the policies, you can see now that at the very top we have now the blocking policy, which directly blocks the DNS requests coming from our clients. And we can verify that as well by just running again the same test as before. And as you can see now, the DNS requests actually time out, which would effectively block any botnet from communicating, for example, with its dedicated DNS servers. If we go briefly to our GitHub, I can show you as well that, for example, 2 minutes ago, another backup was pushed, there was a change, and then over the history, I could review those changes, directly drill down what changes were performed, and I can use that backup as well to restore the system back to its previous state in case I needed to. I hope you found the last couple of minutes interesting. If you want to reach out to us, feel free. You can reach me either on LinkedIn or you can just email. I would be really happy to hear from you if you want to maybe see the demo demonstration again, maybe in live, or maybe you want to see something else, or if you just want to have a chat, feel free to reach out to me, and have a great day.